A technique that we can use is what's referred to as a net present value profile. Net present value profiles show us how net present value changes as discount rate changes. This is particularly useful in industries with changing financial costs. Now, this is a table that's created in one of our capital budgeting workbooks. There's actually one that's called Net Present Value Profile Worksheet. As you see here, we have our two projects, A and B. Here's the expenses, here are the cash flows that we expected. Now, on this data table, we've listed or input a variety of potential weighted average cost of capital. It then calculates for each project, here's project A, project B, it calculates the net present value with each of these costs of capital. As you can see in the very beginning, A, 25,837 is greater than B, 23,000 odd. But as we go down the list, sooner or later, right around 9%, it looks like, not looks like, it does, net present value is now greater for B than it is A, and it is that way for the remaining weighted average cost of capitals. We'll talk about this over the next couple of slides. So if we graph this, if we put this in a graph, what we can see is the two lines, blue is A, project B is the orange color here. Where these lines cross the zero axis, that designates the actual internal rate of return. The vertical axis represents the net present value at the differing weighted average cost of capital for the projects. And again, note that there are places where, or parts of this graph, where A has a higher value, net present value, than B. But then if we continue over, we see that that switches, it changes. So what we talk about here is we're talking about a conflict. We'll talk about that here in a second. But they don't always give the same answer. A little bit better example, a little bit wider description shows us here's project L. Again, it has higher net present values in the beginning than S does, but it changes. There's a crossover point right in the middle. What is that crossover point? In this example, it's 8.7%. It just says if your weighted average cost of capital is likely to be less than 8.7%, L is better than S. However, if you think there's a chance, and again, we may want to statistically analyze that, but if there's a chance that your weighted average cost of capital will exceed 8.7%, S is the better project. So when comparing two projects, this crossover rate kind of tells us where preferences might shift. Another way we can do this is what we refer to as project risk analysis or analysis itself. So using the projects here, you can see that actually I've switched these from the beginning thing just to make this a little easier understanding. But we want to calculate what's referred to as the incremental cash flows. All you do is take project A's cash flow and subtract from it project B's cash flow. So negative 60,000 minus a negative 45,000, that is negative 15,000. Again, the reason I switched these is I wanted the cost with the highest cost to be the first project. That way we start out with a negative number over here. It just makes the analysis a little cleaner. Down below, we've calculated our net present values, our internal rate of returns. The incremental cash flow, if you calculate the net present value of the incremental cash flow, in this case it's negative $1,017. The question is, should we do project A? If it's negative, it obviously means you should not. And indeed, it's kind of obvious. 10,000 is greater than 9,000, but they're pretty close. The crossover rate for this particular project, 7.07%. There are several reasons why net present value profiles conflict with each other. Two are the, I guess, kind of fundamental, not fundamental, it's the wrong word. Two of them are structural, right? Different size companies, different size projects will create different relationships. They change the slope of the line, if you will. So in this case, higher opportunity costs, the more valuable these funds are. So a high required return is going to be favorable for small projects. Timing differences, though, project faster paybacks, provide that more cash flows earned in early in reinvestment. So if the required return is high, early cash flows are especially good. Now, a more fundamental reason for this is really a mathematical issue. It's kind of a philosophical issue, if you will. Internal rate of return calculates the average return each year of the project. It assumes that internal rate of return is the future discount rate for future cash flows. This is not realistic, especially for very profitable projects. Net present value calculates the value, but bases its decision on current discount rates. It assumes that future cash flows will be invested at whatever the discount rate is at that point in time. And this is how we assume all investors should invest. So there are conflicts between net present value and internal rate of return. It's important for us to understand those conflicts when we're analyzing this data. Another technique is called the modified internal rate of return, MIRR. This addresses a flaw in internal rate of return by assuming the reinvestment at the reinvestment rate, not the project's internal rate of return. In addition, this helps us for projects that might not have cash flows that reflect normal cash flow patterns. Quite simply, all it does is says, look, if you reinvest all of your future cash flows, what will the cash flows be at the end of the year? They refer to this as a terminal value. We know what the cost is. That's the investment cost. That's a present value. The terminal value is a future value. We know the time of the project. So MIRR solves for the rate of return between the present value, the investment, and the future value, the terminal value of this project. It just makes it a little, it takes care of some of the issues we may have with internal rate of return. So in this example, modified internal rate of return, the reinvestment rate you see is 13%. Modified internal rate of return is 17% for A. It is 15% for B. Again, both projects exceed the reinvestment rate. They're both acceptable projects, but again, A is better than B. Look forward to seeing you in the next video.